Hello everyone and welcome to this, my video on solving for the denominator. But the denominator of what? Trigonometry, because I'm continuing my trigonometry series. My name's Darren from MaffsGuru, yep, my little corner of the internet where you can head over and get the downloadable lesson notes from the stuff I'm doing behind me, the videos and so much more. Hopefully you'll do me a massive favour before I get into this and subscribe to my YouTube channel. Very needy and rightly so. It means the world to me. So very few people watch my content. That if you're watching and you can subscribe, it just lets me know that someone out there has watched and just gives me that little bit of, I don't know, push to keep doing it. All right, I love what I do here, and I wish more people watched it, but it's the way it goes. Right, that's the needy stuff from me. What are we going to do? Know how to use trig ratios to help you find the lengths of missing sides of a right-angled triangle where the denominator of a fraction is. Well, if we go back to what we did previously, and I'm going to use the last example I just talked about a moment ago. The cosine of 20 is equal to x on 3. All of the examples we had previously had the missing letter on the top of my fraction. All of them on the top of my fraction. But what happens if it's on the bottom of my fraction? What if this was actually the other way around and I had 3 on x? How do I get the x on its own? And that's a little bit of an algebra trick, all right? Long story short, and I don't know if I've got a slide coming up, what you can actually do is for trigonometry, you can actually swap these two over. All right, and the reason being, and I'll show you the reason why in a moment, but here's the shortcut. The x actually moves up, the 3 stays where it is, and the cosine 20 goes on the bottom. And now I've got something I can type into my calculator. Life is really good. But let's do the why this works. If I've got the cosine of 20 equals 3 on x, I don't like fractions, so what do? Well, I want to get rid of the divide by x. So what do I do to both sides? I times by x. So I'm going to multiply that side by x, and I'm going to multiply that side by x. So what that's going to leave me is x times the cosine of 20 is equal to 3. Right, but I want the x on its own, so that's not really helped me, has it? Because the x wasn't on its own here, and it's not on its own there, but I've got a times by that I can undo. So I can undo that times by cos 20 by dividing both sides by cos 20. Now when I do that, that disappears, leaving me the x on its own. The 3 was there, and I divide by the cosine of 20. So that's the algebra reason. But what you notice is, effectively, the x was on the bottom, the cos 20 was on the top, the x is now on the top, and the cos 20 is on the bottom. So that's a shortcut, but with the reason why. That shortcut becomes really handy. Okay, again, don't forget, the most important part for this, if you've watched my previous videos, you'll know that I get very excited about this, is being able to label the triangle in the right way. If you get the labels the wrong way around, it doesn't matter what you do from that moment on, it's going to be wrong. Likewise, if your calculator's in the wrong mode, and again, I've got the DEG up here, if your calculator's not in degrees mode, you're going to get horrible answers. So probably the best thing to do now is make sure your calculator's in the right mode, particularly if you want to play along. Right, Pythagoras' theorem, we know that we're probably going to need to use this if when we're given two sides, we have to find the third one. And again, if we do just a quick example, if I say that that's 3 and that's 4, now let's choose 6 for example. The easiest way to do this is we know that when you use Pythagoras' theorem, this squared plus this squared is equal to this squared. So what I tend to do is go 3 squared is 9, and I tend to write it down, I go 9. 6 squared is 36. Add those two together gives me 45, which means that this here is going to be the root of 45. And that's going to make my life so much easier. I don't need to do c squared equals a squared plus b squared and write all the working out down. I can start to use my head. The reason being is Pythagoras' theorem is just helping me with the trigonometry. It's not necessarily the core purpose of the question. Make sense? Hopefully. Right, surds. We know what surds are. Surds are effectively numbers that can be written under a square root. So root 3, root 5, root 7, root 11. You'll notice there I didn't do root 9. The reason being is that root 9 would actually be 3, because 3 times 3 is 9. So don't get tricked here with the root 9. Just realize that sometimes, particularly for these questions, life is much easier to write things in roots or surd notation to make our calculations just a little bit easier. Right, Here we go. So let's just recap this one more time. If we had this question here, what would he do? Well, what I would be doing is saying, well, where is my x? Is it on the top or is it on the bottom? If it's on the bottom, I know I can just switcheroo. He's doing it the wrong way around. Switcheroo, switcheroo. So where I start with cos of 35 is 2 on x. I know that the x and the cos 35 can swap places. So I know that x becomes 2 on cos 35. And again, I can quite literally put that into my calculator. And now I'm going to go control and divide. When I do control and divide, I get that beautiful little fraction thing on the TI Inspire. I don't know what the case would be for the class pad, but what I've got now is do 2 divided by trig, cos, and 35. And then when I hit enter or control and enter in this situation, because my calculator is in exact mode, I would get 2.44 and life is good, right? So in that situation, I'd say that x is equal to 2.44 to 2 decimal places. So knowing where that x is becomes really, really important. So again, if I'd had this as the cos of 35 is x on 2, there's no switcheroo. I wouldn't switcheroo. I would just times both sides by 2 to get rid of that divide by 2. You only switcheroo when you got the divide by x on the bottom.